Hello friends, welcome back to my channel Path of Physics. Today in this video we are going to discuss about a problem. So the question is this: calculate the rate of increment of the thickness of ice layer on a lake when thickness of ice is 10 centimeters and the air temperature is minus 5 degrees Celsius. If thermal conductivity of ice is 0.008 calorie centimeter inverse Celsius second inverse degree Celsius inverse, density of ice is 0.91 into 10 to the power 3 kilogram per meter cube and latent heat is 79.8 calorie gram per meter. How long will it take the layer to become 10.1 centimeters? So we have to find the rate of increment of the thickness of ice layer and also how long the time taken for the ice layer to grow from 10 centimeters to 10.1 centimeters. So temperature of ice is given, it is minus 5 degrees Celsius. Let it be theta 2, and temperature of water, of course we know it is 0 degrees Celsius, let it be theta 1. When water converts to ice, heat is released, so heat energy flowing per second is denoted by H. It is equal to dq by d2, where q is the amount of heat flowing, and dq by dt is equal to Ka times delta theta by x. This is our equation number 1, where K is the thermal conductivity of ice and A is the area and delta theta is the temperature difference, x is the thickness. If dm is the mass of ice formed in time dt, then dm by dt is equal to rho a dx by dt, where rho is the density of ice. Now we know that dm is mass. So mass is equal to density times volume, and this volume can be written as area into thickness. So this for dm mass, the for dm mass it can be written as density into area into dx thickness. So dm, it is dm by dt. So the equation becomes rho a dx by dt. This is our equation number 2. Now h is equal to dq by dt. It is already written in equation number 1. Now in the next step, dq by dt can be written as dm by dt times L. dq is actually equal to dm times L. It is from the equation q is equal to ml. Here water is getting converted to ice. So this L is the latent heat of fusion. If it is dq, then it is dm times L. Okay. So dq by dt is equal to dm by dt times L. Now this dq by dt is already given, it is h. So replacing dq by dt with h, we get h is equal to dm by dt times L. This is our equation number 3. Now we are substituting the value. We have already found the value of dm by dt from equation 2. We are substituting it. This is our equation 2. Dm by dt equals rho a dx by dt. So from this we are going to substitute for dm by dt. We get h is equal to rho a dx by dt times L. Now this is our equation 4. Now equation 4, if you check equation 4 and equation 1, both are equal. Equation 1 was this one. H is equal to dq by dt is equal to Ka times delta theta by x. Now this equation 1 and equation 4 are equal. We can equate it. Then we will get Ka times delta theta by x equals rho a times dx by dt times L. Now cutting this A and rearranging the equation, we get dt is equal to rho L by K delta theta x dx. This delta theta is theta 1 minus theta 2. We know what is theta 1 and theta 2, okay? The last step we substitute all the values and find the required answer. Now integrating on both sides, we get integral 0 to t dt is equal to rho L K delta theta integral x1 to x2 x dx. Now integral dt is t within the limits 0 to t. Now rho L, this is equal to rho L by K delta theta. Now integral x dx is x square by 2, x square by 2 within the limits x1 to x2. Now putting the limits on next side, on next step, we get t is equal to rho L K delta theta x2 square minus x1 square by 2. Now why we are integrating it? Why we are integrating in this step? Integrating both sides, we get time taken for ice layer to increase its thickness from x1 to x2. We have to find how long. The question was how long will it take the ice layer to increase its thickness from 10 centimeters to 10.1 centimeters. 10 centimeters is our x1 and 10.1 centimeters is our x2. Okay. So we have found the equation T is equal to rho L by K delta theta into x2 square minus x1 square by 2. This is our sixth equation. Now substituting the values, we are before that, what all are the values? Delta theta is equal to, I already told you, delta theta is theta 1 minus theta 2. Theta 1 was 0 degrees Celsius and theta 2 is minus 5 degrees Celsius. So 0 minus minus 5 is 5 degrees Celsius. Delta theta is 5 degrees Celsius and rho, it is already given. It is a density 0.91 into 10 to the power 3 kilogram per meter cube. Now here in this question almost all the values are given in CGS units. So we can convert this density into 0.91 gram per centimeter cube. Now latent heat is 79.8 calorie gram per meter. Now x1 is 10 centimeters, x2 is 10.1 centimeters as I told already. Now K is 0.008 calorie centimeter inverse, second inverse, degree Celsius inverse. These all are the values given. So substituting this in our equation number 6, we get T is equal to 0.91 times 79.8 by 2 into 0.008 times 5 into 10.1 square minus 10 square. We get T is equal to 1824.52725 seconds. So this much time is required for the ice layer to increase its thickness from 10 centimeters to 10.1 centimeters. Now we have to find rate of increment of thickness. Okay, now rate of increment of thickness is given by dx by dt. Now from our equation 5, what was our equation 5? This was our equation 5. On rearranging this equation 5, we can write dx by dt equals k delta theta by x rho L. Now on substituting the values, k's value is 0.008, delta theta is 5, x is our thickness 10. 10 into density is 0.91 into 79.8. We have to find the rate of increment of thickness. So we are taking here the x1 value 10 centimeters. Okay. Now dx by, on calculating it, we get dx by dt equals 5.5 into 10 to the power minus 5 centimeter per second. So we have found the rate of increment of thickness. It is 5.5 10 into 10 to the power minus 5 centimeters per second. And we have also found the time taken for the ice layer to increase its thickness from 10 centimeters to 10.1 centimeters. So that's all for today. Thank you.